that the last time he sent the money, it was not enough to buy all the provisions.
Oh, sorry, I forgot to tell him.
Are you guys talking about money transfer to buy provisions?
Yes.
But don't you know about Baluwo?
Baluwo? What is Baluwo?
Baluwo is a service that your son can use to send provisions directly to you guys from the shop. And you don't have to worry about the exchange rate.
Tell me how Baluwo works.
It's very simple.
Just log on to baluwo.com and shop, or download the app on your phone. You can shop on the website or using the app to buy online basic products for your family and friends. With Baluwo, you decide what your money is spent on. Your money, your choice. Buy online products for your family and friends in the Gambia, Senegal, Nigeria or Mali. Baluwo, better than sending money.
Hi, you're watching Kerr Fatou. My name is Buba Gajigo, and this is your educational program. We're gonna bring you primary school lessons. If you have kids at primary school level, please get them prepared. Give them a pencil and a book. I hope you will enjoy these lessons.
Are you thinking of owning your dream homes? EJ Investment is here for you. Secure our quality bungalows with 2, 3 or 4 bedrooms, or our story buildings 3 or 4 to 5 bedrooms at very affordable prices with flexible payment plans at our Sanyang Seaview Estate, where you can enjoy the cool breeze with modern infrastructure such as tar roads, covered drainage system, modern electrification with street lights, gated entrance with security posts, and social amenities such as gas station, shopping mall, medical clinic, park, schools, children daycare, and a lot more. Our dedicated team of professionals will keep the estate clean at all times, provide security and patrol team within the estate premises, install latest technologies such as CCTV, Wi-Fi, home network installation, solar panel, and power backup system. Also, check out for our additional home facilities and interior design service such as premium tiling, wall plaster, home landscape, fingerprint home lock, and a lot more. Visit our office at Senegambia Kololi Highway and get a free site visit tour, or contact us on 4464-838. WhatsApp us on 3259220. Or you can visit our Facebook page or Instagram on EJ Investments. EJ Investments, we are first in properties.
Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you.
Good day, viewers and our listeners. Welcome yet to another lesson under the lower level, that is LBS. In this lesson, we are going to discuss equivalent fractions. If you are following the program keenly, you realize that you've treated fractions in lesson 7, and our second lesson on the fractions is going to be equivalent fractions. In this lesson, we are going to learn more about equivalent fractions. We are going to deal with how to find, if you're given a fraction, how to get it equivalent. Also, when you're given two fractions, how do you determine whether those two fractions are equivalent? We also talk about the definition of equivalent fractions. So without wasting much time, let's start the work. Key terms, that is the definition of equivalent fractions. We say equivalent fractions can be defined as fractions with different numerators and denominators that represent the same value or proportion of a whole. We'll talk more on the definition of equivalent fractions in the next slide. We'll move right to the slide. Here you are giving 3 pictures. They are all circles, of course. The first one, as you see, it is written one whole. We have one complete circle. The same circle is divided in 3 ways. If you look at the second circle here, the circle is divided into 2 parts. The first part here we have 1 all over 2. The second part here is 1 over 2, which is referred to as half. The second circle, I will call it B, and the first one I would like to call it A. So circle B, well, it's the same whole that is divided into 4 equal parts. So this part here is 1/4, and all the other parts are 1/4, 1/4, 1/4, 1/4 respectively. And circle C, which is the same whole, is divided into 8 parts, 8 equal parts. If you look at it, you realize that each part is labeled as 1/8. That is 1 all over 8. So we want to look at circle A, B, and C and examine what is their relation. You can see it is the same whole that is divided into 2 in circle A. Equally, the same whole is divided into 4 in circle B. And equally, the same whole is divided into 8 parts in circle C. Looking at it also, you see that part of these circles are colored. In circle A, half of the circle is colored orange. Circle B, the same thing is happening, and circle C, equally the same thing is happening. But each and every one of these circles is divided into different proportions. Of course, each is divided into equal proportion at the circle level. That is, A have equal proportions, B has equal proportions, and C has equal proportions. Now we are going to compare the sides that are colored yellow. If you look at it in general, for all the 3 circles, all of them are divided into 2 wherein it is colored yellow. Let's talk about the first one. The circle is divided into 2, and half of it is being colored yellow. If you look at the second circle, it's divided into 4, but half of it is colored yellow. The third circle, that is circle C, is divided into 8, and half of it is colored yellow. We want to look at the relationship between the parts that are colored yellow. If you look at the first circle, we only have 1 all over 2. That is as part of that is colored yellow. If you look at circle B, the part is colored orange, I meant to say. If you look at circle B, the part that is colored orange is 1 over 4, and 1 over 4. Remember, the circle is divided into 4 equal parts. So 1/4, that is 2 1/4 are colored orange in the circle. So we have 2 1 over 4s, that is going to give us 2 all over 4. I would like to take that again. In circle B, it's divided into 4 equal parts, and each part represents 1/4. So the proportion that is colored orange in the circle, there are 2 parts that are colored orange, and each part is labeled as 1 over 4. So if you're going to count how many 1/4 in this circle is colored orange, if you count that, we are going to have 1, 2. There are 2 parts. That is why we are going to, we write that as 2 all over 4. Again, we look at the third circle, that is circle C. It is divided into 8 equal parts, and half of the circle is colored orange. So we are going to look at the side that is colored orange. How many 1/8 in the circle are colored orange? You realize that we have 1, 2, 3, 4. That is 4 proportions of 1/8 are colored orange in that circle. So if we were to determine the shaded region, that is the colored region in circle C, we will count 1/8. How many 1/8 are there that are colored orange? Count. We have 1, 2, 3, 4. So there are 4 1/8 that are colored orange in circle C. So we have 4 all over 8. Now, what is the relationship between these fractions? The first one, we have 1 all over 2. The second one, we have 2 all over 4. And the third one, we have 4 all over 8. Let's look at these 3 fractions based on the diagrams, then we come down to the numbers. If you look at the diagrams that we have, that circle A, B, and C, they are all divided into equal parts. And the parts that are colored in the 3 circles are equal. So what we simply mean here is, in circle A, the region that is colored orange is equal to the region that is colored orange in circle B, and is also equal to the region that is colored orange in circle C. So what I am trying to draw at is, the regions that are colored in each circle is equal. So if the regions that are colored in each circle are equal, then we can conclude that the fraction that represents each region that are colored in the circles are also equal. That brings the idea of equivalent fractions. You will see that the first fraction, the region that is colored orange is 1 over 2. This is equivalent. And again, the symbol for equivalent is that, but normally we use this in high level. So in this level, we are going to use the equal to sign as equivalent, as you'll find it in many books, that the equal to sign there is used as equivalent. So if you go to higher level, don't be surprised to see this other symbol that shows equivalent. So we will say that 1 over 2, to get back to the lesson, we say that 1 over 2 is equal to 2 all over 4, which is also equal to 4 all over 8. All these the proportions in the 3 circles that are colored orange are equivalent. You realize that the fractions may be different, but they are equivalent. Going back to our definition of what fractions are, we said they are fractions with different numerators and denominators. So let's go back to what we realized. The first fraction that we have is 1 over 2, which is equal to 2 all over 4. You realize that their numerators are different.
so as their denominators. They are also different. Yet they are equivalent fractions because they represent the same proportion in the two diagrams. To continue with the definition, we have that represent the same value or proportion of a whole. So looking at each and every one of these fractions represents an equal proportion in circle A, B, and C. So generally, the concept of equivalent fractions is to make sure that the proportion that is represented in each diagram is equal, even if the fractions that represent the proportion in their individual diagrams differ. In a nutshell, I'm saying if you have 1/2 as the proportion in the first circle, and you have 2/4 as the proportion in the second circle, we say these two fractions are equivalent because the proportions that they represent in these circles are equal. In general, that's what we refer to as equivalent fractions. You move to the next slide, and here we have a little bit of problem. Don't worry, we are going to enjoy it because we are going to answer all the questions and we'll proceed to the next one. So this question is saying, how many 1/4 pieces fit in half pieces? Fit in half piece rather. How many 1/4 pieces fit in the half piece? The second question is asking, can you write the answer as a fraction? Yes, you will do all that, so don't worry. Just relax and I will get you through all that. Now, if you look at it, the first diagram that we have on this side is half of a circle, which represents the half piece here. It represents the half piece that is discussed in the question. Also, the 1/4 piece that you are seeing here in yellow color represents the 1/4 piece that is discussed in the question. So you are asked, how many 1/4 pieces can you have in this half piece? We have a circle that is divided into two parts. Only one part of it is what we are seeing here. And we have another circle that is divided into 4 parts. Only one out of those 4 parts is what we are seeing here. Now what we are asked is, how many of the one that is divided into 4 parts can you have in the one that is divided into 2 parts? So if you want to take this inside here, like we try to compare it using the diagram, you'll come to realize that 2 of the 1/4 will be in the half. The circle that is divided into 4 parts, 2 of it will fit in the circle that is divided into 2 parts. If you just take half of the circle that is divided into 2 parts. So if you take that, you realize that 2 of it is going to fit here in the other part of the circle. So that answers the first question, that we have how many 1/4 pieces fit in half piece. So we are going to have only 2 pieces that 2 pieces of 1/4 that will fit in 1/2. The second question is asking, can you write the answer as a fraction? Can you write the answer, that is, how many 1/4 pieces fit in half piece of a circle? The answer is yes, we can write it as a fraction, and because of the fact that 2 pieces of the 1/4 fits in the 1/2, then the answer for the second question is going to give us 2 all over 4. That is, 2 of the 1/4 pieces fit in the 1/2 piece. I hope we all get that. All right, we'll look at the second example. It's similar with the previous example. We are asked, how many 1/6 pieces fit in 1/2 piece. That is to say, if you have a circle and you divide the circle into 2 equal parts, and you take one of those equal parts, and you take another circle of the same size with the previous circle, and you divide it into 6 equal parts, and you take one part out of those 6 equal parts, how many of those 6 equal parts will fit in the circle that you divided into 2 equal parts? That's what we are going to find out now. That is to answer the first question. The second question went further to ask, can you write it as a fraction? We'll try the first question first, then we will look at the second question. We are going to find out how many 1/6 pieces can fit in this half piece of the same circle of equal proportion. So we take one of it, put it there. We have one piece, then we take another piece, rotate it a little bit, and then we have it there. Now, as we are counting, there are 2 pieces that fit so far, 2 pieces of 1/6 that fit in the half circle, that is half of the other circle. Then we take another one and see. Let's rotate it and see. Okay. We get this done very soon. The question is not difficult. We are almost here. Done. We are. If you look at it, you realize that 3 pieces of the 1/6, that is 1/6 piece, fit in half. There are 3 pieces that fit there. So the answer to the first question is 3 pieces. 3 pieces of the 1/6 fit in the half circle that we have. Remember, both circles are of the same size, and the first circle is divided into just 2 equal halves. You take one of those halves, and the second circle is divided into 6 equal parts. So you just take one out of those 6 parts, and we want to find out how many of those 6 parts can fit in the half part that we had previously. So now we realize that we have 1, 2, 3. We have 3 equal parts that fit in the half circle. That answers the first question, saying how many 1/6 pieces fit in a half piece. The second question is saying, can you write it as a fraction? Yes, it can be written as fraction. All we need to know is how many of the pieces can fit in it. Already, we've established that 3 pieces of the 1/6 is what fits in the half. So in order to write this as a fraction, how many pieces do we have? We have 1, 2, 3 pieces. So we are going to have 3 all over. Remembering that the circle was divided into 6 equal parts, so our denominator is going to be 6. So we have 3/6 of the 6 pieces that can be put together in order to form the half piece that we are giving. I hope that is clear as well. So we move to the next. Okay, we look at this other example. We are asked how many 1/6 pieces fit in a 1/3 piece. I would like to take that again. How many 1/6 pieces fits in 1/3? I'm the one controlling, huh? Okay, we take the question. It's asking how many 1/6 pieces fit in a 1/3 piece? How many 1/6 pieces fit in a 1/3 piece? The 1/3 piece here is referring to a circle that is divided into 3 equal parts. A circle that is divided into 3 equal parts. Just one of that is here, is what we are taking. Also, we have another circle that is divided into 6 equal parts, but the 2 circles that are divided are equal. We put that into consideration. The 2 circles that we are dividing, the first one we divided into 3 equal parts, and the second one we divided into 6 equal parts. They are all of the same size. Just that the first circle is divided into 3 equal parts, and we are taking one of that, which gives us 1/3. And the second one is divided into 6 equal parts, and we are taking one out of those 6 parts, which gives us 1/6. So the question is, how many of those 6 parts can fit in the 1/3? How many of the 1/6 equal parts can fit in the 1/3? So we are going to do that. Hence we have both diagrams here. We are going to take them and put them together on top of each other so that we can see how many of the 1/6 parts will fit in the 1/3. To do that, we get 1. We have 1 that is 1/6 that fit in this other one. One of the piece that is divided into 6 equal parts. We already put it in the circle that is divided into 3 equal parts. Remember, we only take one part of the circle that is divided into 3 equal parts. And equally, we note that both circles are equal. So we try to take another piece and fit it and put it there. We'll need to rotate the 1/6 piece a little bit. All right, I think that will do. So we rotate it just a little bit to have it. Yes, that will do. So you will see that we have another piece of 1/6 that fit in the 1/3. So what do we realize? We realize that 2 pieces of the 1/6 piece is what fits in the 1/3 piece. 2 pieces of the 1/6 piece fits in the 1/3 piece. So if we are going to write this in fractions, how many pieces of the 1/6 piece fit in the 1/3? 2 pieces. We count 1, 2. So we are going to have the 1/3 is equal to 2 of the 1/6. The 1/3 that we had previously is equal to 2 of the 1/6. So we are going to have 1/3 is equal to 2/6. 1/3 is equal to 2/6. As you can see, linking from the previous section, we still have our 1/3 piece, and we still have the 1/6 piece that we used to fit in the 1/3 piece. It's saying we show equivalent by writing both fractions with an equal sign. That is, to show that the 2 fractions are equivalent, we use an equal sign to show that both fractions are equivalent. As I said earlier, there is a symbol used as equivalent, which is this symbol, but for this level we are going to use the equality sign as equivalent. You can see that we have 1/3 here, that is 1/3, is equal. Here we have another fraction, but the numerator, we only have a box there, and the denominator is 6. What it simply means there is the first circle here is divided into 6 equal parts. into 3 equal parts rather, and the second circle is divided into 6 equal parts. And in the diagram here, we equally have the same thing. We have a circle that is divided into 3 equal parts, and one part of it is brought here, that is 1/3. And we have another circle of the same size divided into 6 equal parts, and 2 pieces fit the 1/3 that we are given. So how many 1/6 did it take to cover the 1/3? How many 1/6 pieces did it take to cover the 1/3 piece? How many pieces did it take? We have 1, 2. So in this box we are going to have 2. Now to buttress more on it, to show that the two fractions are equivalent, we make sure that the number of pieces of the 1/6 fit in the 1/3 are two pieces. So in a nutshell, we can say that 1/3 is equivalent to 2/6. We'll come to see more of these examples in the lesson further. All right, here we have a fraction bar or fraction bars. The fraction bars below are equivalent because they are the same size. That is, they have the same size. We'll try to compare maybe half of what we have. That is, from this point to this point, we understand that this is the whole and this is half of the whole. So we are going to compare that with all what we have here. Let's extend that and see what we have. You will see that all these regions are equal, but they are divided into different proportions. So the half that we have here can be equivalent to 2 of the 1/4 that we have. So 2 of the 1/4 is simply we are adding the 1/4 here and the other 1/4 here to be equal to the half. So we can say half is equal to 2 of the 1/4 is 1/4 plus another 1/4. Well, if you do the mathematics there, you're going to have half is equal to 2/4. Also, you can equally compare the half with the 1/6. If you look at the 1/6 here, how many 1/6 do we have here under the half? We have 3 1/6. We have 1, 2, 3. We have 3 1/6. So we can say that the half there is equal to how many 1/6? 3 1/6. So we're going to have 3/6. So these two fractions are equivalent. We can have more of these examples from the fraction chart. We can have another one, like if you look at, again, looking at the same boundary, that is half here, it is equivalent to this other area. We have 1/8. So how many 1/8 will you add to give you a half? We can still have that in the fraction chart. We have half is equal to, if you add how many 1/8? 1, 2, 3, 4. If you add 4 1/8, it will give you a half. So that is 1, 2, 3, 4. So that is going to be 4/8. So we have 4/8. So equally, we will see that half is equal to 4/8. The evidence of this is what we are seeing already here on the board. Again, we can do it for 1/12. We can do it for 1/10. Let's try the one for 1/12 and move on to other examples. So equally, if you look at it, you will see that we have the same half that we have. And how many 1/12 can we add in order to give us a half? We count from our fraction chart. You have 1, 2, 3, 4, 5, 6. So we are going to add 6 1/12 to give us a half. So we can equally say half is equal to, how many 1/12 do we add? Let's count. 1, 2, 3, 4, 5, 6. We add 6 1/12 to give us a half. So we are going to have 6 all over 12. You can equally use 1/4 because half is not the only one we have here. We can equally use 1/4. So if you want to extend, if we extend this line down to this region, now we are only considering that. And we use a different color. We are only considering this. And we'll extend our line to see which ones does it tally with. So you realize that the 1/4 is equal to, well, it's not equal to the 1/6 because they are not equal from the chart. But if you look at 1/8, you can add 2 1/8 to give you a 1/4. You can add 2 1/8, that is 2 1/8 to give us a 1/4. So we can say the 1/4 there, 1/4 is equivalent to 2 1/8 is written as 2 8. So we are going to have 2 all over 8. Let me write that somewhere here. So we're going to have 1/4 is equal to 2 1/8, that's just 2 8s. So we're going to have 2 all over 8. So even by looking, you will realize that we can even add other fractions to give us 1/4. So what other fraction within this region can we add to give us 1/4? We can add 1/12. How many 1/12 can we add to give us a 1/4? We count 1, 2, 3. So we can add 3 1/12 to give us a 1/4. So we can equally say 1/4 is equivalent to 3 1/12. So that's going to give us 3 12s. So there we say 1/4 is equivalent to 3 12s. So we move to another example, if you have any. Okay, we look at this order fractions. We have the fraction bar that's the same with the other one. These fraction bars below are equivalent because they are the same size. That is, they are of the same size. So again, we have wholes that are divided into equal proportions. If you look at the first whole here, it's divided into 3 equal parts. If you look at the second whole, it's divided into 6 equal parts. The third whole is divided into 9 equal parts. And the fourth one is divided into 12 equal parts. But all the wholes are equal. Again, we are asked, what do you notice about the denominators in each set of equivalents? Well, let's look at the denominators. Okay, let's find some equivalents before we look at the denominators. So we like to concentrate on this side. On the 1/3, we are going to concentrate on the 1/3. And then we are going to compare the 1/3 with the other fractions and see, that is the other parts of the wholes that we have under the 1/3, and see which ones can you add together to a certain number, and it will give us the 1/3. That is, the 1/3 is equivalent to which fractions are in the chart. So we take the first one. If you look at 1/6, that is a whole divided into 6 equal parts. Remember, all the wholes are equal. And this whole is divided into 6 equal parts. What will you see? If you add this to 1/6, it will give you a 1/3. So if you have a whole and you divide it into 3 equal parts, and you have the same whole and divide it into 6 equal parts, so you need 2 of the ones divided into 6 equal parts to add it together in order to give us 1 of the one that is divided into 3 equal parts. So what I'm saying here is, in order to have a fraction that is equivalent to 1/3, you need 2 fractions of 1/6 added together to give you one that is equivalent to 1/3. So we need 2/6 in order to give us a 1/3. We can equally do that for 9. That is, we have a whole and it is divided into 9 equal parts. So what we are doing here is, we have a whole that is divided into 9 equal parts, and of course we are comparing it with a whole that is divided of the same size, that is divided into 3 equal parts. The question is, how many equal parts on the whole that is divided into 9 equal parts can you add together to give you 1/3? That is the whole that is divided into 3 equal parts. As you can see, we have 1, 2, 3. We have 3 equal parts out of the 9 equal parts that you can add together to give you 1/3. So we can have 1/3 is equivalent to 1, 2, 3. If you add these 3 equal parts, it's going to give you 3 all over 9. That's 3/9. Let's try to compare this 1/6 with the other fractions underneath. Let's try to compare the 1/6 with the 1/9. 1/6 here, how do we have it? Is a whole divided into 6 equal parts. So each part there is 1/6. That is 1/6. So we are going to compare it with a whole that is divided into 9 equal parts. So we want to see if a part in the 1/6 will be equivalent to some parts in the 1/9. As you can see, if you want to do the direct comparison, we have 1/6 there, 1/9 there, but the other 1/9 is being divided by 2. So we'll come to realize that 1/6 cannot be equivalent to 1/9. So that is out of the game. But we can go further to look at 1/12. Well, 1/12, if you compare it with 1/6, you realize that you have 2 1/12s that you can add together. That is 1/12. And remember, the way we get the 1/12 is we have a whole and divide it into 12 equal parts. So each part is 1/12. We are trying to compare that with a whole that is divided into 6 equal parts, and each part is 1/6. So if you do the direct comparison, comparing them directly, you realize that you will add 2 1/12s to give us a 1/6. So there we can conclude that 1/6 is equivalent to 2 1/12s will give us 2 12s. So we're going to have 2 all over 12. In a nutshell, what we are trying to say here is, if you compare the portion that is divided into 12 equal parts and the portion that is divided into 6 equal parts, 2 out of the portions divided into 12 equal parts is equivalent to 1 portion that is divided into 6 equal parts. So what we say is, the fraction that is 1/6 is equivalent to 2 of these ones, 2 of the 1/12s. So we are going to have 1/6, that is 1/6 is equivalent to 2/12, which is 2/12. So you can, if you have the chart at home, you can have so many fractions here that are equivalent. Just have to make sure that you follow the trend I am following in order to fish out which ones are equivalent and which ones are not equivalent. And also, if you are finding the ones that are equivalent, you'll have to add. Like for instance here, we have 2/12. Although in the equal parts you have 1/12, 1/12, 1/12. But if you add 2 1/12s, it is going to give you 2/12s. So you need to put that into consideration as well. So we move forward. All right. Again, here we are saying to create equivalent fractions, you can multiply the numerator and the denominator by the same number. Here what we are trying to say is, whenever you are giving a fraction, you are given just a fraction, one fraction, and you are asked to find another fraction that is equivalent to the fraction that you are giving. So what can we do? What we have here is to create an equivalent fraction, to create equivalent fractions rather, you can multiply the numerator and the denominator by the same number. Let's try to do that here before we look at the example that we have. Take any fraction. Take any fraction. Maybe I like a half, so I will take a half. So I will take 1/2. And what I want is to find another fraction that is equivalent to this fraction. And we are told that you can multiply the numerator and the denominator by the same number. Okay, here you can take any number to multiply the numerator and the denominator, but it should be the same number that you multiply to the numerator and also the denominator. If you do that multiplication, you are going to have a fraction that is equivalent to the fraction that you multiply that constant to. So we choose a number, maybe we take 4. We are going to multiply the numerator by 4 and multiply the denominator by 4. The answer that we are going to have, as the fraction that we are going to have, is going to be an equivalent fraction to the one that we have previously. So as you can see, we are multiplying the numerator by 4. That is, the numerator is 1 and the denominator is 2. Remember, we are dealing with the fraction half. We are multiplying the numerator by 4 and we are multiplying the denominator by 4 as well. So when you multiply the numerator by 4, that is 1 times 4 is going to give us 4. All that over, let me rewrite that. We have 1 times 4 is going to give us 4. All that over 2 times 4. 2 times 4 is going to give us 8. So we have created another fraction that is equivalent to the fraction that we have previously, that is half. We multiply both the numerator and the denominator, and we have 4/8. So these two fractions, half and 4/8, are equivalent. That is 1/2 is equivalent to 4/8. Let's try to see what we have here. All right. We have, that's what I'm referring to. We have 2/4 and the numerator is multiplied by 3. Equally, the denominator is multiplied by 3. When you multiply 2 by 3, that is the numerator by 3, the answer is 6. And when you multiply 4, that is the denominator, by 3, the answer is 12. So we can say that the fraction that we have, that is 2/4, is equivalent to 6/12. we have 2/4. 2/4, that is the first fraction that we have there. When you want to find its equivalent fraction, we said you can multiply the same number by the numerator and the denominator, and we can see that's what is happening. We multiply 2 by 3, that is the numerator 2 by 3, and also the denominator 4 by 3. When you multiply 2 by 3, the answer is 6. So we have 6 all over. The denominator is 4. When you multiply it by 3, the answer is 12. So 4 times 3 gives us 12, so we have 6 12s. So we can conclude here that 2/4 and 6 12s are equivalent fractions. That is 2 all over 4 and 6 all over 12, they are equivalent fractions. We can have more examples of that. You can be given any fraction. You can pick a fraction. I wish you were here to pick a fraction, but I'll pick it for you. Let's say 4 over 5. We have a fraction 4 all over 5, and we want to find another fraction that's equivalent to the fraction that we have here. Can we find another fraction that is equivalent to the fraction that we have here? Yes. All we need to do is get a number. You can use any number excluding 1, because you realize that when you multiply 1 by 4, it's just going to give you 4. If you multiply 1 by 5, it's going to give you 5. So it's like you are repeating the same fraction. So any number that you multiply by this fraction, we multiply it by the numerator and also by the denominator, it will give you another fraction that is equivalent to the fraction that you have. So this time, let's see what number will be multiplying at. This other example we multiplied by 3, this other example we multiplied by 4. So let's see whether we can multiply by 2. We are going to multiply the numerator and the denominator by 2 in order to create another equivalent fraction. So what we have is 5 all over 4. That is the numerator here is 4 and the denominator is 5. So we're going to multiply the numerator by 2 and also the denominator by 2. What is this going to give us? It is going to give us a fraction that is equivalent to 4 over 5. So 4 times 2 is going to give us 8 all over. 5 times 2 is going to give us 10. So what do we realize? We realize that when you multiply the numerator by 2, that is 4 by 2, we have 8, and the denominator 5, when you multiply it by 2, it gives us 10. So from here, we can conclude that 4 all over 5 is equivalent to 8 all over 10. So 4 over 5 and 8 all over 10 are equivalent fractions. So you can equally try this at home. You can pick any fraction. You can multiply it by any number other than 1 to avoid having the same fraction again. But the rule is you have to multiply the number by the numerator and also the same number by the denominator in order to have another fraction that is equivalent to the fraction that you have. So you can try 10, 20 examples and you realize that you will have equivalent fractions. Let's move to another one. Now we are asked to think. Use our heads now. Can you think of another way to find an equivalent fraction that has a smaller numerator and denominator? If you look at the first method that we use here, we have a fraction and we multiply it by 2. You realize that the equivalent that we are going to have will have a bigger numerator and a bigger denominator. So in this other one, we want to make sure instead of having a bigger numerator or a bigger denominator, we want to have a smaller numerator and a smaller denominator. So how do we do that? Yes, it's possible. That is how it is done. I will take you through. Maybe we'll have our own, and then we discuss what is written over there. Let's say we have 8 all over 10. We have a fraction, not so. We want to have an equivalent fraction that is smaller, that has a smaller numerator and a smaller denominator than the one that we have here. Well, I'm sure you must have seen this already, saying you can also divide the numerator and the denominator by the same number to find an equivalent fraction. So what we can do in multiplication, if you have a bigger number, you can divide by a number you will divide the numerator by a number and also divide the denominator by the same number, and you will have another fraction that has a smaller numerator and a smaller denominator that is also equivalent to the fraction that you have. So in this example, 8 all over 10, what number can we use to divide 8 and 10 without any remainder? Of course, when you're dividing them, you make sure there is no remainder. 2 can be divided through. So we are going to divide 8 by 2, and we're going to divide 10 by 2, and we're going to have another fraction that has a numerator and a denominator smaller than the numerator and the denominator that we have. That's what we are doing. So if you divide 8 by 2, of course, if you're following the lesson, you know how to divide, so you don't have to go back there. 8 divided by 2 is going to give us 4. We have a division line, or the fraction bar, sometimes we call it. So we have 10 divided by 2. 10 divided by 2 is going to give us 5. What do we realize? 8 all over 10 is equivalent to 4 all over 5. Our intention is to get an equivalent fraction to 8 all over 10, wherein the numerator of that equivalent fraction will be smaller than the numerator that we have, and the denominator is also going to be smaller than the denominator we have. Well, exactly that's what we have. I hope we are already enjoying this. Because when we divide 8 by 2, we have 4, and we divided 10 by 2, we have 5. 8 all over 10 is equivalent to 4 all over 5. From there, we look at what we are given to examine whether what we have there is also correct. The fraction that we have here is 6 all over 21. We want to find another fraction that is equivalent to 6 all over 21, but in that case we want the numerator of that fraction to be smaller than the numerator that we have, and equally the denominator of that fraction to be smaller than the denominator that we have. That the fraction that we are going to have, its numerator should be smaller than 6, and its denominator should be smaller than 21 rather, because the fraction that we have right now is 6 all over 21. So we look for a number that can divide the numerator and the denominator without any remainder. Well, such number is 3. If we divide the numerator by 3, that is 6 divided by 3, and we divide the denominator by 3, that is 21 divided by 3, you are going to have 6 divided by 3 is 2, and 21 divided by 3 is 7. So let's look at the two numbers. 2 is smaller than 6, and 7 is smaller than 21, and that's what we are trying to look for. We are going to look for a fraction that is equivalent to 6 all over 21, and we equally want the fraction to be in such a way that the numerator of the fraction will be smaller than 6 and the denominator of the fraction will be smaller than 21, and consequently that's what we have here. We have 6 all over 21 is equivalent to 2 all over 7. So those two also are referred to as equivalent fractions. Try questions that I want you to do is, what fraction is equivalent to 3 over 2? We said you can, 2 over 3 rather. We said you can, if you have a fraction, you can find another fraction that is equivalent to that fraction. We use two ways of doing that. One is using multiplication and the other one is using division. You see which one is feasible in these questions and apply them and find the equivalent fraction of 2 all over 3, and also what is an what other fraction that you have, or can you have that is equivalent to 2 all over 6, as well what other fraction can you have that is equivalent to 1 all over 8. So those are the 3 questions that you need to find their equivalent fractions. That brings us to the end of the lesson. And again, I will leave you with a piece of advice when it comes to our health in this time, pandemic we have. Always remember, we should always adhere to the advice of our health workers. Stay at home, make the best use of the lessons that you're having, and of course, exercise hygiene. Make sure your hands are always clean, and when you know that they are dirty, avoid touching your eyes, nose, or mouth. So thank you all for your kind attention.
Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you. Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you.
Good day, viewers and our listeners. Welcome yet to another lesson under the lower level, that is LBS. In this lesson, we are going to discuss equivalent fractions. If you are following the program keenly, you realize that you've treated fractions in lesson 7, and our second lesson on the fractions is going to be equivalent fractions. In this lesson, we are going to learn more about equivalent fractions. We are going to deal with how to find, if you're given a fraction, how to get it equivalent. Also, when you're given two fractions, how do you determine whether those two fractions are equivalent? We also talk about the definition of equivalent fractions. So without wasting much time, let's start the work. Key terms, that is the definition of equivalent fractions. We say equivalent fractions can be defined as fractions with different numerators and denominators that represent the same value or proportion of a whole. We'll talk more on the definition of equivalent fractions in the next slide. We'll move right to the slide. Here you are giving 3 pictures. They are all circles, of course. The first one, as you see, it is written one whole. We have one complete circle. The same circle is divided in 3 ways. If you look at the second circle here, the circle is divided into 2 parts. The first part here we have 1/2. The second part here is 1/2, which is referred to as half. The second circle, I will call it B, and the first one I would like to call it A. So circle B, well, it's the same whole that is divided into 4 equal parts. So this part here is 1/4, and all the other parts are 1/4, 1/4, 1/4, 1/4 respectively. And circle C, which is the same whole, is divided into 8 parts, 8 equal parts. If you look at it, you realize that each part is labeled as 1/8. That is 1/8. So we want to look at circle A, B, and C and examine what is their relation. You can see it is the same whole that is divided into 2 in circle A. Equally, the same whole is divided into 4 in circle B. And equally, the same whole is divided into 8 parts in circle C. Looking at it also, you see that part of these circles are colored.
In communication, connectivity is everything. We ensure that the links never sleep. Quantities and qualities, all in our data service, providing efficient, reliable voice and data service. We believe if you're not up to speed, then you're going backwards. Communications have to flow as fast as the speed of light. Whatever business you're in, having someone who understands your needs is critical. That is why we just don't offer you technology, we offer you solutions. Enjoy Gamcel's internet broadband anytime, anywhere. Your national operator, Gamcel.
I got it.
Kembe
Bijan aganyadi.
Albaka.
Mbaka important.
Yo, nga transfer la sto.
Ya transfer la.
Ha, code nyingi.
Okay. Korsa. Nsila ID soto.
Ha, sa soto. Sorry. Agada.
Bijan bro.
Albaka.
Mbaka.
Bara la service o tariya.
Ah,
mbare ki janna nun kunu bara tariya.
Jannom yo forest de bureau. Gambia tonkon na no mbari ya bere. Birim koyna fo kato.
Bari si kodo kino kato nim fo bolong blabe to.
56 branches mola sota Gambia jang.
Ha?
Gambia kono ani Gambia bantala bankol. Nka kodo kiya bere. Kodo sifa fo falindiro fo nyaadi lafta memmen na kodi to poto nim kodi maraw. Jannam number 1 di nyonta. Andum fana nata anoda enterprise sotale. Wala nyindi ko domorol fanan kol fanan be firale le dadi ma ni domorol ni fanan be teat. Gambia dawda yalo ma kum fa kendol sotale je.
Wo moyo diat.
Apelenta
ni wo ka ni lafta nyelen kendol e bina.
Yalo bu kanyi la ko la baraka ba.
Yalo ndel chosano lo.
Abaraka.
Touchdown, but I broke down.
Gamtel G-Fiber, now you can enjoy super fast internet in gigabytes. G-Fiber is affordable, stable, secured, and accessible to homes, businesses, and enterprises. With Gamtel G-Fiber, the future is speed. Gamtel, creating a brighter future in communication.
That's how she became mine and see the
Yara nyilla domoro kadiyata.
Boy, janno Sikes restaurant.
Sa nako be ni na dimbal. Nimba domoro kala janno.
Domoro seneyata adiyata topotoro fanan kende ma bije. Luntan during tamala abeka domoro ki janni. Adi manda wala de. Teka we bijele anim fanan ka fadi jang ikono e fa. E ka fa minne ko pastry anim bakery. Iko fanan bekalele. Badde lomba conference lomba workshop lomba ye fo pendin lo dunia kono domoro betama nyillom international o tewoda number 1
amanke ba domola jandama
esa domo jang is atariya
wo mu kubandi
sa nako sa futandin
oto sa nako be mu Sikes restaurant
dafa nan janna mu yat ni manje dorom bija
aban
Sikes restaurant, known for best quality food and customer satisfaction.